Okay, well, this is easy. Try the numbers in your calculator first. This one turns out to be just relatively straightforward, but don't write 4 point whatever decimal that is. No decimals. Okay, square root of 20 is, what we're going to be doing is practicing pulling out perfect squares like the square root of 4, which is 2. Okay, so we're rewriting it that way. 50, 25? If you can't figure out what perfect square you've got, what you do is just break it at all and then look for pairs. I see a pair of 2's. Okay, so square root of 4 and then square root of the leftovers.
3 times 5, 15.
Two times 3 times 5 is not going to be fixable. If there's no pairs of prime factors, if you've broken it down as far as it'll go and there's no pairs of factors, that's it. Okay, next topic is what's called rationalizing the denominator. You multiply the top and bottom by the square root. It mucks up the top, but it makes the denominator nice. Now, why would we like that? Well, there's historical reasons, but you also need to know that 1 over root 2 and root 2 over 2 are 2 different ways of writing the same number. I'm going to stop the intermediate step of writing square root of 9 and just notice that root 3 times root 3 is just 3. Multiply a square root times itself, and the square root sign cancels. We will have to simplify now. So 6 over 3, that's 2. I'm going to write a little note. Okay. Fixing the bottom. Even if the top is cookie, don't multiply by root 3 on the top. You've got to multiply by 1. Okay, so we have square root of 6 over 2, and that's done. Okay, so looking at square roots, and fix this on your actual page.
Sorry, thought I'd fixed it before I printed it out.
I had other things, and then I meant to fix it, and I forgot. But square root of x to the 10th, if we have 10 copies, I'm not going to write this out more than once, but 10 copies of x on the inside is 5 pairs. So it's going to end up being x to the 5 on the outside. Okay, what about x to the 7th when it's not an even number? I'm going to say this is x to the 6th and a leftover x. So what I have then is x cubed times a leftover root x. So it's a lot like the numbers. Let's see, we do this one bit at a time. Okay, square root of 16 is 4. X to the 11th under the square root sign is x to the 5th, and a leftover square root of x. Square root of y to the 18th is y to the 9th, and then we put the square root last. I'll write a little note. The reason for that is that things creep under square root signs if you put things after the square root sign that aren't supposed to be under a square root. So, okay, so now let's take a look at this. Square root of 20 times 5 I can treat 5 squared. I don't have to turn it back into 25, but I can think of 5 squared as just like x squared. 2 copies underneath is 1 copy outside. Of course, could have recognized that 20 times 5 is 100 to begin with, and the square root of 100 is 10. Keep the things outside. So let's multiply the 3 times 2. Looks like I've got another pair of 2s and a 4. So 6 times 2 times 2 times root 3. 4 times 6 is 24. There you go. That was a little tricky. Not too bad. Okay, so what do you do with this one? X squared, y cubed, x to the 5th, y to the 9th. Unlike numbers, since the exponents are small, let's just combine them together. And now that you're at this stage, you don't need to write this intermediate step. If you can see that this is x cubed root x, that's fine. You can go directly to that step. And again, put the square root last.
Oops.